Hi, Rob Pappas here, the EO doctor here at EO University, and we are going to be distilling some frankincense oil today. And the primary reason for doing this is all the confusion in the industry around what type of frankincense has what chemicals in it, and basically you only have the supplier to rely upon for this information. So I contacted some growers of actual frankincense in Africa and the Middle East and asked them to send me samples of not their oil but their actual resin so that I could distill the different species and then analyze them on the GC and determine what is in them. Not only trying to determine what's the difference, but also want to prove without a shadow of a doubt that there is no boswellic acid in frankincense steam distilled essential oil, regardless of some of the claims that you have heard out there. So we will be analyzing these samples and proving that there is no boswellic acid in there, but that's the minor point. The major point is to be able to take the different species of, I've got some Carterii, grade 1 here. I've got some Frariana, grade 1. And today I'm going to be doing the sacra, or sacred frankincense. And another one that I've come across recently that I didn't even know about was the Boswellia Rivae, R-I-V-A-E, which we'll be also taking a look at. But today, like I said, we'll be doing the sacra, and just for my own kind of peace of mind, I'm taking these chunks of these tiers, which you can see, some of them are pretty big, and I'm going to basically pulverize them before I distill. I've already done that with some of the material there. I'm going to do, just a couple 100 grams today. But all you can do, if you get some frankincense resin, just put it into a bag and then get you a little hammer and just pulverize some of those bigger chunks. That'll give you the maximum surface area to distill from, and release some of that oil that might not be released if we left those chunks, those big chunks in there as is. It doesn't have to be pulverized to like a fine sugar or anything like that. Just get those big chunks down to a manageable size, and you'll smell, the odor will become quite a bit more pronounced after doing that. So here's some that I've pre-ground up, as well as this. And what we're going to be doing is using a little home distillation kit that I invented back in 1997, 96, 97, called the StoveStill. It's basically just a pressure cooker, and you see here I've already filled this with some water. It doesn't matter the exact amount, just enough to get, just so you don't run out of water is the key thing. This is just a couple of liters of water, or a couple of quarts. So I could use the platform and put the botanical on top of that, but for this distillation all I'm going to do is place the frankincense resin directly into the pot. So this is a couple 100 grams or so, and yield is typically pretty high with frankincense, so we don't have to use a huge amount of material like we might have to with, say, lavender or other products. Yield can be up to 10%. It usually is between 5 and 10. So this is just basically a modified pressure cooker. Anyone could theoretically do this. These are available if anyone is interested, but I don't really actively try to sell these. Just a modified pressure cooker with a stainless steel adapter drilled into the center of it and mounted so that we can attach our glassware to it. Now this is called a Clevenger. It's just a distillation trap that allows us to collect the oil in this receiver here. And I'll show you as I get it mounted exactly how this works. So first of all, I want to put on a little bit of this silicone grease on the joint so that it is easily removed once we're done. So it makes a nice seal and it makes it easy to remove once we're done. Okay. This is our condenser. It's a cold finger condenser. And it will go right in the top here. And we will vent it with this little piece of aluminum foil. You don't want to seal this off because what will happen is the water in there will boil, and if it's sealed off, pressure will build up. Eventually enough will build up to where this will pop off, and then this will flash boil up into here and it'll be a big mess. So it's best just to leave everything at atmospheric pressure by leaving this little pressure relief up here. Okay, now what we have here is just a small cooler with a submersible garden style pump, and inside of here is also some water. Now we will pump the water through the condenser. It will go into this top inlet here, and as you can see there's a center tube that goes straight through the middle of the condenser and then pushes the water, cold water, back up and then out this spot, this spot here, and it will be recycled back into the cold water reservoir. Now you don't have to use a pump. You can just run cold water from a tap or other source through this. I like to use a cooler because I don't have to waste gallons and gallons of water that way, and I can just recycle the same water, and I can also use some ice to keep this cool. That gives you a really nice, efficient condensing. So we'll turn this on, the pump, and we'll show the water, hopefully, pumping through there. Sometimes we have a little bit of a short on this. There we go. Now you can see the water pumping through that. Okay. Now the way the StoveStill works is it's designed to be used on any kitchen stovetop. As long as you have hood clearance, you're fine. You could also use an external hot plate, gas or electric, doesn't matter. Just something to get the water boiling is all you need. So we're going to heat this up. Turn on the water here. And the water in there is going to boil. It's going to lift the oil out of our biomass, and it's going to come over as gaseous oil and water until it hits this cold finger. when it hits the cold finger, the oil and water will condense, and then it will collect in this trap. And initially it's going to be a lot of water, very little oil, but then as more and more oil comes over, the oil layer will float on top, whereas the water will go to the bottom layer and be recycled back into the kettle. And this will continue to go on. You'll see the oil level grow, and it'll continue to grow. And once the oil stops growing, you know the distillation is done. Normally, you also want to put, I'm going to put a little bit of water in here. Let me get a little cup. Just enough to not let that first bit of oil that comes over go back over and be redistilled. We want to collect all of it the first time. So if we put a little bit of water down here first, that'll stop that from happening. So anything that collects now, the water layer is the only thing that's going to be recycled back over. When we're done, we'll drain off the bottom layer, which will be the hydrosol, and then the top layer will be the oil. So this is going to heat for a little while to get the water boiling, and as soon as we start to see something come over, we'll come back and pick up where we left off. Okay, we're back, and as you can see, we can see some water and oil condensing along the arm here. This is really hot, and it's starting to drip now. It's hitting the condenser and starting to collect. This is the first few drops. It only took about 20 minutes, and we've already started to see some oil coming over. Now, it'll probably be a total distillation time of maybe an hour to 2 hours at the most for this. Some botanicals take a lot longer, but this is a very easy, quick distillation. It's an easy oil to collect because it's a very light oil, very immiscible with water, so it separates really nicely. As you can see, it's already, look how fast that's growing. Normally, most botanicals you'd be distilling for 20 minutes before you'd see that kind of level there. Now, if you start to see too much bubbling going on up here, that means you need to turn the heat down, and I'm going to do that right now. What you want ideally is basically about 1 drop a second coming over, so you don't come over too fast. If it's a little faster, that's okay, but you want a nice even flow, and you don't want this. I got a little too much. I heated a little too fast, so I had to turn it down. And the oil will be cloudy like this in the beginning, but that will that cloudiness will go away as it cools down. When we're done distilling, that will completely go away. It's sort of milky looking right now. Not all oils are like that, but some of them do get that way. Now see, it's not starting to slow down. Now this is about, we're not getting the bubbling up here anymore, so we're doing well now. And if you get going too slow, you want to crank the heat back up a little bit. But as long as you're coming over at 1 drop a second or thereabouts, you're doing pretty good. And I expect to see probably about 10 grams of oil, 10 to 20 grams of oil. So that really could theoretically, I could almost fill up this entire tube with oil when we're done, which is a pretty good amount of oil for just a little home distillation. So this is going to go on for a little while, so we'll cut away and come back when I know that we're completely done and we're ready to shut down, and then we'll take a look at the oil. Okay, we're back. The distillation is now completely done. we've collected, as you can see here, about 23 milliliters, which is 22, 23, somewhere in that ballpark, which is pretty good yield for as little bit of materials we put in there. So probably right close to that 10% range in yield. So what I'm going to do now is first turn off our condenser, and I'm going to collect the hydrosol, which is not much. Now we could keep distilling this indefinitely. I mean, I could drain all this oil off and then I could distill more to get some hydrosol if I wanted to get some more hydrosol. But I'm going to just drain this little bit of hydrosol off the bottom here. So we just start to get oil through there, and then that'll go into a little separate thing, and then the rest of this is going to be oil. Now there is a little bit of water trapped in that arm there that I would like to get out. So I'm going to move the condenser all together. And just so I don't collect any of that water in the oil, I'm going to force all that water down to the bottom so that we can drain all of it out. See, now you can see that water there. And the oil, see, it's not quite as cloudy as it was at first. It's, you know, first it was that real milky color. Now it's just a little cloudy, and that will continue to clear up. And you can speed up the rate that clears up if you want to. If you collect the oil, you can actually put just a little salt in there, and that salt will absorb the water. The reason it's cloudy is there's little tiny bits of water in there, and that salt will dissolve it right out, and it won't dissolve in the oil. So it's a very safe way to clear up oil. Okay, now I've got all the water layer out, and we'll collect the oil. Smells nice. And there we go. Right at 20 milliliters of oil. And you can see that, you can see how cloudy that is. But I could actually just put a little bit of salt in there and it would clear right up if I had any handy. But it will actually, the glass will absorb the water out of it as well. If I just let this set for a couple hours, it'll clear up too. But now we're just going to take the oil and take it to the GC at IUS and analyze it and see what kind of chemistry we have. Thanks, and stay tuned.